This is the story of a supercar that breaks all the rules. A supercar designed like no other, with a squared-off, box-like body, a practical four-seat layout, at an affordable price for this kind of car. Mass-produced on a production line in the ultimate megafactory. It's a multi-million-dollar gamble by a multi-billion-dollar company. Japanese carmaker Nissan builds 5 million cars a year. Not all are created equal. This is the GT-R. Brutal acceleration. A split-second gear change. A hand-built engine. Among the best aerodynamics of any production car.
Some people say this is against the theory of car design.
It takes the fight to the likes of Porsche, Lamborghini and Ferrari at a price that undercuts them all.
This is effectively a giant killer.
Nissan is the world's 6th largest car maker. It has a proud 80-year heritage. But back in 1999, it's on the verge of bankruptcy with a $20 billion debt and outdated cars that no one wants to buy.
It was really pretty dark days for the organisation. With a brand that had tremendous history, tremendous respect, but didn't have the products and didn't have the technology that it needed.
The company appoints a new CEO, Carlos Ghosn, a maverick leader to turn the business around. Of Lebanese descent with French and Brazilian citizenship, Ghosn is one of few foreigners ever tasked with saving a Japanese corporation. He cuts jobs and closes factories, but sells cars. Within 2 years, he turns the $20 billion debt into a $2.7 billion profit.
3 weeks ago, we declared the Nissan revival complete by delivering our most difficult Nissan 180 commitment, 1 million additional sales.
It's one of the most dramatic turnarounds in business history. Ghosn becomes a national hero for saving an iconic Japanese brand. To cement the company's place back at the top table of car producers and to inspire brand confidence, Ghosn takes a big gamble. He decides to reinvent the company's most iconic product, the legendary Nissan GT-R, and nothing but the best will do.
I told them no compromise. I don't care how much time it's going to take. I want a very strong performance car.
Get it wrong, the company loses millions and becomes a laughingstock in the industry again. Vice President of Communications, Simon Sproul, was instrumental in relaunching the Nissan brand.
If you develop a car like the GT-R, you are overtly taking on the very best in the world, and you're making a very big statement. The price of admission is very high, and the cost of failure is very high as well.
Ghosn has just one man in mind for this mission. Chief Engineer Kazutoshi Mizuno. He's been a race engineer, team director and car designer for over 40 years. Crucial experience for creating a car that could revolutionize supercar expectations. Mizuno becomes the godfather of the GT-R.
The supercar market was only accessible to people with specialist driving skills or considerable amounts of money. I wanted to change that by opening up the market and creating a supercar that reflected our customers' needs.
The new car must have 4 seats, a trunk big enough for a set of golf clubs, and still be capable of exceeding 300 kilometers per hour on any road with anyone at the wheel.
I wanted to create a supercar for anyone, anywhere, anytime, where even the customers themselves would become super. That's what I aspired to.
To keep the cost down to just $100,000, he has to rethink the way supercars are built.
People often misunderstand, believing that high-performance cars need to be handmade, but I totally disagree with that.
This will be a mass-produced car, built on a production line. It's a bold idea. Every part of a supercar is exposed to the extreme stress of high speed, so requires ultra-precise assembly. Any error, and the consequences are unthinkable.
Mass-producing a car that can go at speeds of up to 300 kilometers per hour requires 4 to 5 times more accuracy per part, compared with making the same car by hand.
Tochigi, Nissan's state-of-the-art assembly plant, 80 kilometers north of Tokyo, Japan. The size of 600 football pitches, with 5 canteens and a hospital. This is a true megafactory. "6:30 a.m. Over 2,000 workers start their shift. This plant produces 1,000 cars a day. Most are high-volume mid-range models, produced using the latest mass production methods. But 1 in 7 of the vehicles that come down the line is a GT-R. The poster boy of Japanese automotive engineering is assembled by the same people who make 4-door family cars. The production line at Tochigi is over half a kilometer long, with 2 loops consisting of 160 positions. Once the shift begins, the line is relentless. 2.5 minutes is allocated for each position. One GT-R takes 60 hours to build from start to finish. 25 roll off the line every 24 hours. The GT-R may be all new, but the name has a proud history. The very first GT-R emerged in 1969 as a souped-up version of Nissan's 4-door Skyline sedan. This was a road car fast enough to be a race car. Soon, the young Japanese pretender was beating the world's best.
Original Skyline GT, just normal sedan, they put the big 6-cylinder engine. It was fast, and it beat the Porsche. First time in Japanese car racing history.
In the 1990s, the 3rd generation Skyline GT-R was nicknamed Godzilla after destroying its race rivals on the track.
The nickname Godzilla stems from the fact that it came from Japan, that it had this sort of mythical giant-killing ability.
The Skyline GT-R is legendary in Japan. It's revered in popular culture, featuring regularly in the country's manga comics as an iconic hero car. For chief designer Shiro Nakamura, the GTR's unique cultural status must be expressed in every aspect of its styling.
This has to be unique Japanese supercar. We don't want to make another Porsche. We don't make another Ferrari. I wanted to create a totally new language.
In the West, supercars are curved, sleek, and streamlined. The GTR's bodywork is the polar opposite. It's square, angular, and blunt. This angular design takes much of its inspiration from another Japanese graphic creation, Gundam robots.
This form, this is almost like a tube connected to the tail lamp. You can see this delicate surface. This is the muscle. This guy is male, it's not female.
This masculine, robot-inspired boxiness may seem the wrong shape for an aerodynamic supercar, but every bold angle channels air around the GTR's brutal and efficient body.
People tend to think the boxy car is not better for aero. That's not true.
It's here, at the wind tunnel in Nissan's technical center, Tochigi, 45 kilometers south of Tokyo, that the bodywork is put to the test. Chief Engineer Mizuno and his team spend weeks reassessing how the exterior design can make use of airflow and improve the GTR's aerodynamics. A model 40% the size of a real GTR is positioned on rollers which rotate, simulating speeds of up to 300 kilometers per hour. Smoke and laser light highlight the path air takes around the car. The smoother the airflow, the better the aerodynamics, and the lower the drag.
There are no vortices on the body surface. In fact, vortices can't form on the body surface. Even the air at the sides is flowing nicely. This vortex-free design reduces drag.
Aerodynamic efficiency is measured using a number called a coefficient of drag, or CD number. The lower the number, the better. A typical truck has a CD number of about 0.9. Its flat front isn't streamlined, and its large square rear produces turbulent vortices which increase drag holding it back. Due to its more streamlined aerodynamic shape, a standard car has a CD number of 0.35, about a third that of a truck. All the hours in the wind tunnel pay off. The chiseled GTR has a CD number of just 0.26. One of the lowest for a car in production today.
This car has a very, very good aerodynamics. Every detail is designed for better aero.
Aerodynamics is crucial to many aspects of the car's performance. With his racing background, Chief Engineer Mizuno is experienced in getting the most out of the airflow as it passes over the car.
Air that hits the top of the bumper bar or the front spoiler is actually directed sideways. Using the force of this airflow, the braking system is cooled, the engine compartment is cooled, and downforce is produced at the same time.
Downforce is a key part of the GTR's design. As air passes over the car's body, it presses downwards, pushing the tyres into the tarmac. This force gives the car more grip, allowing it to accelerate faster and corner more quickly.
Optimizing that characteristic of so-called boxy design and better aero, we achieved it.
Back at the Tochigi Megafactory, the GT-R starts life here at the body shop. "341 robots join its steel, pressed aluminium and high-tech carbon fibre cabin together, clamping, squeezing and spot welding the body shell. "7,000 welds later, this GT-R gains a roof. And the robot's work is done. The completed cabin is whisked up to a superhighway in the sky. Tochigi operates on 2 levels. The ground floor is where the cars are built, painted and tested. While above, a series of automated conveyor belts move cars and components throughout the factory without disrupting the workflow below. Now the bare GT-R cabin is ferried from the body shop to paint. Only authorized personnel are allowed in the paint booth. Nissan are scrupulous about keeping any dust, which can ruin a paint surface, out, so television cameras aren't allowed in. It emerges to be manhandled into a tunnel of bright lights. Here, the fluorescent glare of 250 neon tubes exposes any minor flaws. Then skilled technicians give the bodywork an expert polish, special treatment for the GT-R alone. It takes up to 3 hours to perfect each car.
I'm very proud to be involved in producing the GT-R. It's a car I've idolized since I was a child.
The painted and polished cabin moves from paint to assembly. It descends from the skyway onto position 1. Here the doors are removed. This gives the workers easy access to the car's interiors. With the doors out of the way, the internal wiring bundles and dashboard are fitted with split-second efficiency. The carbon fibre rear spoiler is attached. And then the body is whisked up and over a factory walkway before continuing along the neighbouring line. In another corner of the assembly plant, the GT-R's engine arrives and is hoisted onto a travelator. A computer coordinates its overhead journey. This engine will rendezvous with its body at precisely the right time back on the main production line. The GT-R's engine is the most powerful production engine Nissan has ever built. It rockets the GT-R from 0 to 100 kilometers per hour in just 2.8 seconds. The engine is built in Yokohama, 30 kilometers south of Tokyo. Every GT-R engine is crafted by hand. High-performance engines cannot be mass-produced. To keep contamination to a minimum, the engine is assembled in a sealed clean room. Over 4 hours, one of 13 highly skilled artisans, known in Japanese as Takumi, builds each engine from start to finish. General Foreman Mr. Kurosawa appreciates the Takumi's vital input.
The worker plays a central role in what we're creating. Can I call it a work of art? We're not just creating an engine, but an accomplished piece of work for everyone's satisfaction.
The starting point is the 6-cylinder engine block. As it arrives at the assembly room, the block's air cleaned and etched with a unique number. And then passed through an airlock and into the clean zone, where a master craftsman awaits.
When looking at assembly jobs, I doubt there are many where you could build an entire engine from start to finish on your own. So in that respect, I believe being chosen to work here is really important.
The tension on every nut is critical. A $1 million machine verifies the torque. Next, the Takumi prepares the pistons on a 60-degree hot plate. They expand with the heat. This allows the technician to install a tightly fitting pin. Every piston is hand-selected for an ultra-tight fit. The cylinder head is bolted in place. Now the engine is fine-tuned to perfection. The Takumi measures and, if necessary, adjusts vital clearances within the engine's moving parts to within a 100th of a millimeter. A gap too big or small will compromise the engine's performance. No automated production line can achieve such high precision. It's the human touch that makes all the difference.
The specifications have been narrowed down to about half that of an ordinary engine, which is incredibly tight. So when these craftsmen assemble these engines by hand, they're going beyond what machines can do. This is very different from a mass-produced engine.
Almost complete, the 250-kilogram engine is conveyed outside the temperature-controlled clean room to be mated with its turbochargers. Turbochargers are one of the simplest, most compact ways to increase an engine's power without increasing its weight. They can add up to 50% more horsepower by forcing extra air and fuel into the engine. Fully assembled, the engine is ferried across to the dyno room, where it started for the very first time. In an hour-long assessment, 38 tests verify everything from horsepower output to torque. This data, individual to each engine, is saved and given to the new owner. Still, the workers worry whether they've done enough.
It's terrifying because we don't decide whether this is a well-performing GTR engine, the customer does.
Although this hand-built engine is powerful, Chief Engineer Mizuno chose the V6 for its size rather than its power. Its compactness allows him to position it within the car for perfect weight distribution.
I want to make it clear that the role of the engine is not just to give power to the car. We need to consider the center of gravity of the engine and its weight mass.
By positioning the two heaviest components, the engine and transaxle, over the front and rear wheels respectively, Mizuno achieves perfect weight distribution. This balance gives precise handling. Mizuno's next trick is to get the engine's 545 horsepower onto the road effectively. To do this, he throws the car design rulebook out of the GTR's window. Conventional thinking dictates that a lighter car accelerates faster. At 1,700 kilograms, the GTR is heavy for a supercar, but it still achieves 0 to 100 kilometers an hour in 2.8 seconds. By spreading the GTR's mass evenly across all four wheels, Mizuno maximizes grip and acceleration. Weight distribution is key to the GTR's supercar status and smooth ride.
Our customers can even enjoy having a conversation at 300 kilometers per hour or enjoy cornering on a circuit at 2.9 G. This is all possible because of the GTR's weight design. Anyone who tells me a good car is one that's light, with low power-to-weight ratio, is an amateur.
Back at the factory, the engine arrives at a circular drivetrain sub-assembly line, which runs parallel to the main production line. Here, the engine is paired with the GTR's transaxle, which contains a gearbox. The GTR's transmission changes gear in 200 milliseconds and is put together in an hour. Nagoya, 270 kilometers west of Tokyo. Here, the Aichi Kikai plant is home to the GTR's gearbox assembly room, an area that aspires to aerospace levels of cleanliness. The room is kept at a higher pressure than outside, ensuring a constant outflow of air and contaminants. Just like the engine, master craftsman the Takumi hand-build the gearbox, assembling its 19 cogs in just 7 minutes. The 6-speed automatic gearbox is state-of-the-art. It's the world's first independent rear-mounted dual-clutch transmission. Dual clutch means one for the odd gears and one for the even. When you change into odd, the next even gear is set and waiting. Gears change in the blink of an eye, giving the driver much smoother acceleration.
We can't have a transmission that feels jumpy and jerky when changing gears and has problems with friction and backlash. As soon as the pedal is pressed, the engine should generate power smoothly, with precision. The driver should accelerate as one with the car.
The Takumi house the gearbox in its casing and flush it with oil before it enters an ultra-sealed room where its most intricate parts are fitted. Finally, it's delivered to a high-tech testing machine that verifies the transmission's split-second shifting speeds.
With using this final tester, we can guarantee not only the quality, but also the performance for the customers.
The whole production line relies on this testing machine being in tip-top condition.
This machine is the only one all over the world. So if this final tester is broken, we cannot produce this transmission for the customers.
Working perfectly, the machine puts the gearbox through its paces in just 10 minutes. It's passed the test and is pushed out of the clean room and heads straight for Tochigi. Here, a worker constructs the rear transaxle, transmission, brakes and suspension unit. Job done, he fine-tunes the suspension. Using a test rig, the technician aligns the suspension geometry, so the handling will be perfect. The green light tells him it's bang on. The GT-R suspension is another world first. It monitors weight distribution across the car. Every 100th of a second, onboard computers adjust the suspension units, even taking the driver's mass into account. This achieves maximum grip across all 4 tires.
Ideally, when braking, accelerating or cornering a car, the load on each of the 4 tires, or its grip, should be equal. That's the best condition. That's why we developed an asymmetrical suspension system to correct weight distribution and ensure load is always evenly distributed between the 4 tires.
A forklift carries off the combined brakes, transmission and suspension to the drivetrain assembly line. The drivetrain assembly line swings round to meet the main production line. A computer has calculated exactly which model of car is where on the main production line, and it's coordinated a drivetrain to meet that car. It's crunch time for these line workers. Drivetrain fitting is complicated for all the models at Tochigi, but more so for the GT-R, where an extra worker is needed to perform this task.
The most difficult thing about building this GT-R is attaching the drivetrain. Usually, work is carried out in teams of 4 at the body mount stage. But because the GT-R is a special car and we have to attach the clutch shaft, we assemble in teams of 5.
The 5th worker is another Takumi, a highly skilled technician able to fit the GT-R's complicated drivetrain. What makes the GT-R's drivetrain difficult to fit is the combination of all-wheel drive and rear transmission. Power must be delivered from the engine via a prop shaft to the rear gearbox and onto the rear wheels. But because the GT-R uses all-wheel drive to provide phenomenal grip, power must then be transferred back via a second prop shaft to the front wheels. This means there's almost double the work. This is a time-limited operation. The line doesn't stop. First, the transaxle is hydraulically lifted into the rear of the car. Then the engine is bolted into place before the two prop shafts are connected. Thanks to the fifth man, this can all be achieved in just 15 minutes. Job done. The Takumi returns to the start of drivetrain assembly to prepare for the next GT-R. Back on the main line, the GT-R gains its exhaust, super lightweight alloy wheels, and nitrogen-filled tyres. Regular air is considered too unstable for this supercar. The seats and steering wheel are fitted, and the car is reunited with its doors. Finally, workers add its dashboard display, an item without which no GT-R is worth its badge. The onboard dash display gives detailed information about the car's performance and has always been a big part of the GT-R's appeal. For the new car, the decision was made to update this feature. To do so, Mizuno turned to an old friend, Kazunori Yamauchi.
The first car I ever bought with my own money was a GT-R. So it's a sports car that has a special place in my heart.
But it's an unusual choice. Mr. Yamauchi is no car designer and has never worked for an actual car company before. He's the president of Polyphony Digital, the creator of a video game called Gran Turismo. This game simulates driving thousands of different cars in hyper-real fashion. It's sold millions of copies around the world, and it features every GT-R ever made. Yamauchi is the father of this virtual phenomenon, but he's never had the opportunity to apply his passion to a real car until chief designer Mizuno asked him to create the computer display for the new GT-R.
The request I received was really simple. He said, I want you to submit the greatest thing you can come up with.
Gran Turismo players get a constant blow-by-blow update of how well they're driving in the virtual world. For Yamauchi, there was no reason GT-R drivers in the real world should not get the same.
I love to drive, and I drive every day. By doing this, I realized that gaining this knowledge while you're driving is actually a form of entertainment in itself.
The multi-function display Yamauchi and his team come up with delivers a wealth of information on the drivers and the car's performance, from G-forces to steering angle. This has only ever been experienced by video game enthusiasts before.
By having information appear, driving becomes anything but boring. You experience a level of enjoyment like nothing you've ever experienced before.
GT-R built its reputation and got its name in the virtual world first. So to have that technology in the car kind of adds to the coolness, the mythology, the unexpectedness of GT-R.
back at the factory. After its first drink of fuel, the almost complete car is revved up and off the production line and into the inspection zone. Here, workers shift it through all 6 gears, rocket it up to 130 kilometers per hour, and test the brakes. Then it's into another tunnel of bright lights to check for any paintwork imperfections. Given the OK, it's driven onto a jack and the underbody fitted, before finally gaining its badge. Now, it's off to burn some rubber. Every GTR undergoes a punishing 30-kilometer bedding in. Kazuo Shishikura is the test driver who puts each car through its paces.
We drive at about 50 to 60 kilometers per hour on rough roads to really jolt the suspension and wheels.
The brakes, clutch and transmission are also worked hard to ensure they're race ready. Again, the GTR is the only car produced at Tochigi to receive this special treatment.
As soon as the customer takes receipt of the car, they can drive it on a race circuit.
Every day and night, a team of 10 test drivers thrash 25 GTRs around this test track. It's an enviable job.
It's fun, but it's definitely not my car. It's the customer's car. So, of course, we treat the vehicles with the utmost care when carrying out our tests.
Back in the factory, after a wash and dry, this GTR is on its way to its new owner, joining the 4,000 shipped around the world every year. But Chief Engineer Mizuno is never satisfied. He strives to improve his masterpiece. Every year, he rolls out a new variant to keep this car evolving.
We create a new product every year because we want to unveil something new to our customers every year. By continuously developing the car, it shows our seriousness and dedication.
This year's version has an engine boosted by 20 horsepower, enhanced aerodynamics, and superior suspension. And if that's not enough, there's also a race version available to add more spice to the beast from the east.
Even now, I'd say that I've only been able to achieve about 80% of what I initially wanted from the GTR. As for that remaining 20%, I want our customers to be eagerly awaiting the GTR's evolution.
This isn't the end of the story. This is just one of the chapters, and I think that's the really cool thing about a vehicle like the GTR.
After developing cars for close to 40 years, the conclusion I've come to is that cars are not just things. They're things that create emotions and excitement. We're providing someone with a best friend. That's my conclusion.